Hey guys, this is lesson 10.1, quadratic functions. Now, quadratic functions, you got to take down some notes. A quadratic function looks like this. Y equals ax squared. So we still have our y out front, but then it always has an x squared. So a quadratic function, write this in your notes, is a function that can be written in the form y equals ax squared plus bx plus c. So they add on the other two pieces. Now this one up top, that just said ax squared because that's the most important part. The x squared is what qualifies it as a quadratic function. So there's many different ways. If you look at these examples, they're all written in standard form. So you have y out front of all three, and you have x squared first in all three. And then this one doesn't have anything else. This one has a plus 7, and then this one has all three parts, a, b, and c. So a quadratic function has a graph that's in the shape of a parabola. If you remember that word, the parabola, it's the U-shaped graph. They look like this, and they go up or down. The property is called symmetry. So this is the symmetry is super important for parabolas because they are completely symmetrical. I can draw a line and split them in half. So this axis of symmetry is where the line is that divides the parabola into two matching halves. So make sure you have an axis of symmetry down. Now the vertex is the highest or lowest point of a parabola. So if the, now I drew two little parabolas over here. If the parabola opens up like this one, it's opening upward. The vertex is right here, and this is the minimum. It's the minimum, the lowest point. If the vertex goes down, this point right here, the vertex, is the maximum because that's the highest point. So just make sure you have these written down in your notes. Okay. So here's what they're going to ask you. Identify the vertex of each graph. Tell whether it is a minimum or a maximum. So try this with these two graphs. Okay, so this vertex is right here. It is at 1, 2, and that is a maximum. It is the maximum point of all the other points on the graph. This vertex is right here, and that is at 2, -4, and that is a minimum because it is the smallest point on the entire graph. Pretty simple. So now they're going to ask you to graph these parabolas, and they'll give you all different types of equations. So here's an example. Y equals 1/3 x squared. The easiest way to graph is to make a table. However, you don't always know what to put in your table to get your parabola because the parabolas can be all over the place. So I kind of just try to do -2, -1, 0, 1, and 2. And if you can't see your parabola, you might have to do a couple more parts. So if I do -2 and I square it, because I have to do that first, order of operations, that's 4 times 1/3 is 4/3. -1 squared is 1 times 1/3 is 1/3. 0 times 1/3 is 0. 1 squared is 1 times 1/3 is 1/3. And 2 squared is 4 times 1/3 is 4/3. So if I graph this, I'm going to go -2 and then I'm going to go up 4/3. I go -1 up 1/3. 0, 0 is right at the origin, over 1 up 1/3, over 2 up 4/3. So here is my parabola. And then you continue it, and it has a U shape, and it's going upward, and the vertex is at 0, 0. Now, the vertex is at 0, 0 because I only had one term in this equation. So it makes it pretty simple. So use the graphs below, order the quadratic functions. Okay, so here's 3 quadratic functions. And they want you to order them from the widest graph to the narrowest graph. So you don't have to do this, just watch how I do this, okay? Now, notice that two of my equations are negative. So this and this are both negative. If you see a negative equation, that means it's going to open down, like this one and this one. See how they both open down, okay? Now, this one half is opening upward, and that is my widest graph. I can tell right off the bat. So I'm going to put this one here, and it's 1/2 x. You'll notice if you have a smaller number out front, your graph gets really wide because you're dividing it in half, so it's making it wider. And it grows slower. It doesn't grow as fast because you're cutting it in half each time. However, if you have a 3, it grows really fast. It goes, like, imagine if you're doubling something if you're squaring something and then timesing it by 3, it's going to grow really fast. So my numbers get really big really quick. So that one goes there. And then this is the standard x squared parabola, but it's negative, so it opens down. So this is from widest to narrowest. Okay, so to graph quadratic functions of the form y equals ax squared plus c. So what you're going to do is you're going to graph both of these equations and notice the differences between them. So first I have y equals 3x squared, and then I'm going to make a table, and I'm going to use my same numbers again. And then I'm going to graph y equals 3x squared minus 2. Okay, so here, negative 2 squared is 4, times 3 is 12, 1 times 3 is 3, 0 times 3 is 0, 1 times 3 is 3, and 4 times 3 is 12. So I go negative 2 up 12. It's off my graph. Negative 1, 3, 0, 0, 1, 3, and 2, 12. So I have a pretty skinny graph because it's tripling. So every time I did the squared part, I'd have to times it by 3. So it's going pretty fast. Now this one, if I have negative 2 and I square it, I get 4 times 3 is 12, minus 2 is 10. 1 times 3 is 3, minus 2 is 1. 0 minus 2 is negative 2. 1 times 3 minus 2 is 1. And then 2 squared is 4 times 3 is 12, minus 2 is 10. So if you look at this one, I go negative 2 and 10, negative 1, 1, 0, negative 2, 1, 1, and 2, 10. So if you look at the difference, they're the exact same parabola. However, it's bumped down 2 spaces on the y-axis. So this number right here is still your y-intercept. If you look here, this was a 0. So that was my y-intercept there. This number, the last number, C, is what they call it. C, A, B, and C. This number is your y-intercept. It's very similar to a linear equation. A monkey drops an orange from a branch 26 feet above the ground. The force of gravity causes the orange to fall toward the earth. So they give you the function. H equals negative 16t squared plus 26. Gives the height of the orange H in feet after t seconds. Graph this quadratic function. So what you're going to do is first you're going to make a table. And you're going to have t and h or x and y, whatever you want to do. Now, h is the feet after t seconds. So t seconds, I can't have negative seconds. I can't say the monkey dropped the orange negative times. So I'm going to start with 0 and go up and just do a couple numbers. So I have I have to grab a calculator real quick. Okay, so first I have 0. That's pretty simple. 0 squared times 16t is 0 plus 26. So that's 26. So then I have 1 squared times negative 16 plus 26 is 10. 2 squared is 4 times negative 16 is negative 64 plus 26 is negative 38. Now I can stop there because I know if it gets negative, then that is going to be, it's going to be past the ground. So here's what I'm going to do. I'm going to go 0 and then I'm going to do 26. I'm going to go up by 5s, 10, 15, 20, 25. So over 0 up 26, make a dot. Over 1 up 10. And then over 2 down 38. So that's way down here. So if you look at this, this is only half of the parabola. It's the positive half. So the monkey is up here on the branch. I don't even know how to draw a monkey. There it is. And he drops the orange. So this just shows how fast it takes. 1 1,000, 2 1,000, and it already hit the ground. So if that was 2, it would hit the ground somewhere between 1 and 2 seconds. So that's all you have to do is plug it in and graph it. All right, that's it for your notes for 10.1.